Okay, so we have our polynomial f of x equals 2x to the fourth minus 5x squared plus 8x minus 7, and we want to find f of 6. So I'm going to show you two ways of doing this. So by direct substitution, what that means is I'm going to sub a 6 in everywhere that I see an x value. So every single place that I see an x, the 6 goes in, and I'm going to simplify. So I get 2592 for the first term, 180, 48, and then minus 7, which gives me 2453 for a final answer. If I chose to do synthetic division, I'm going to set up my process here. 6 goes in the half box, and then I have a 2. I'm missing x to the third, so I need a 0, -5, 8, and -7. And I'm going to use the synthetic division process to solve this problem. So these numbers get a little bit large. So I get 410. When I multiply, I get 2460, and when I subtract, I get 2453. So I end up with 2453. Now, you notice they're the same answer, okay? So what you notice here, what do you notice about the value obtained after direct substitution and the remainder? They are the same. So we're just going to say they are the same. Okay, so basically what the remainder theorem is now going to tell us is that the remainder, so the remainder when you divide the polynomial f of x, if I go in a general sense here, by x minus r is the same as f of r. So the value you get when you just sub the number in is going to be the same as if you were to choose to do synthetic division. So applying the remainder theorem using synthetic division to evaluate a function, it's called synthetic substitution. So we're sort of putting both ideas together. Synthetic substitution for that. All right. So when we talk about a depressed polynomial, that means that the quotient that is left after dividing a polynomial by one of its binomials, it is 1 degree less than the degree of the original polynomial. So we've sort of already encountered that when we've written our final answers. But when we talk factor theorem, let's fill this in first. So it says the binomial x minus r is a factor. So is a factor of the polynomial f of x if and only if, so if and only if f of r is equal to 0, which means that the remainder is 0. So the question is asking us, is it a factor? Well, if it's a factor, then we're going to get a 0 as a remainder value. So let me show you what we mean by this, because this is now going to lead into finding all the zeros as these polynomial degrees keep increasing. So it says determine whether x minus 3 is a factor of that polynomial. Then we're going to find the remaining factors. So set this equal to 0. We're going to use synthetic division to do this. So 3 goes in the box. Our coefficients, nothing's missing. So 1, 4, -15, and -18. 1 comes down. Multiply, add, multiply, add, multiply, and we get a 0 remainder. So what that 0 shows is yes. Let's just go with x minus 3 is a factor. Okay, so what we want to do is we want to find all of them. So let's take what's left. So we have 1, 7, and 6. So that's x squared plus 7x plus 6. We're going to set that equal to 0. That's a trinomial. I need two numbers that multiply to get 6 and add to get 7. Well, that's 6 and 1. So x plus 6, x plus 1. And now I'm able to list out what my 3 zeros are. So we said x equals 3 worked because we got a 0 remainder. And then with the x plus 6, I get -6. And with the x plus 1, I get -1. So those 3 zeros match up with the degree of the polynomial from the original problem, which they do. All right, second one here, final one. So it says determine whether x plus 1 is a factor. So -1 goes in the half box. We've got 1, 1, -16, and -16. 1 comes down, multiply, add, multiply, add, multiply, add. So yes, x plus 1 is a factor. So let's take what's left. So we have x squared minus 16. Set that